Welcome, ladies and gentlemen. So what I'd like to do is show you how to graph a system of linear inequalities when we don't have one or two, but we have not even three, but we have four inequalities. So I just thought this would be kind of quick, to go through, because a lot of students, when we do two, they're like, all right, I get it. And we do vertical, they're like, ooh, okay. But now we're just going to add, everything together and determine the feasible region. So I'll try to make this kind of quick. I just want to kind of go through, a couple examples, because I think it's really, really important for students to have this really down pat. So remember, y is greater than 0. Well, remember, when 0, that's going to be a horizontal line. Now, at 0, that's going to be at the x-axis. Y is greater than is going to tell us that it's going to be a dashed line. And greater than is going to be all the values above. OK? So we basically just kind of go from left to right. At x is greater than 3, remember, x equal to 3, that's going to be a vertical line. So I'll take green here. I go over to 3. That's greater than, so that's going to be a dashed line. All the x values that are greater than 3 are going to be going to the right. OK? Then we have the next one is x plus y. X plus y is greater than or equal to negative 2. Let's go ahead and solve that. X plus y is greater than or equal to negative 2. So let's subtract the x, subtract the x. Y is greater than or equal to negative x minus 2. Remember, when you have a negative, that can really be rewritten as a negative 1 over 1. So I go down to my y-intercept at negative 2. And then I can go down 1 to the right one or up 1 to the left one. And that is greater than or equal to, so that's going to be a solid line. And greater than is going to tell us that it's going to be all the values that are above. OK? And then we have our last one, which is y is less than 4x. So therefore, we'll go ahead and use blue here. No, not blue. I want blue. Where's my blue? Here's a blue. So let's go ahead and use blue. So y is greater than 4x. Basically, our y-intercept is going to be 0. And then our y-intercept is our slope is up 4, 1, 2, 3, 4, over 1, or down 4, 1, 2, 3, 4, to the left one. That is less than, so that's going to be a dashed line. And that's going to be values that are, ooh, I see where that's at. OK, so that's going to be values that are, oh, I'm sorry, less than. So that's going to be values that are below that. OK, so now we got to be able to determine where is the feasible region that is only true for our inequalities that we selected. So we basically have an unbounded region that's going to follow here to go to here, and then all the way from here. So it's basically going to be this region, which is unbounded, is going to be our feasible region. OK? For the next one here is we have a lot of equations. None of them are in slope-intercept form. Perfect, right? Great. So happy to do that. So let's go ahead and write them all out so we can solve. So I'll have x plus y is less than 5. I'll have x minus y is less than 4. I'll do x plus y is greater than negative 5. And I'll do, not green, let's do red. And I'll do x minus y is greater than negative 2. OK, so the only reason why I wanted to do that was, again, just so we can go through our inverse operations, because it's pretty important. So here we're going to subtract an x, subtract an x. So I have y is greater than negative x plus 5. Here I subtract an x, subtract an x. I have y is greater than negative x minus 5. Over here, I'm going to subtract an x, subtract an x. So I have negative y is less than negative x plus 4. But I'm solving for a negative 1, so I have to, or I'm solving for a negative y, so I have to divide by a negative 1, which is going to now make me flip the sign. So that becomes a positive x minus 4. I have to do the same thing over here. Subtract an x on both sides. I have negative y is greater than negative x minus 2. Divide by negative 1, divide by negative 1. Remember, the negative 1 divides into both of those. So it's y is now less than x plus 2. Now, the other good thing about this problem, or the reason why I chose it, is because we need to make sure we remember that there is a 1. That kind of looks too much like the other ones. Let's see. Another cool color. I'm using all my good colors. remember there is a 1, orange works. Remember there is a 1 as a coefficient for each of my equations. And also remember that we always, when we're doing graphing, we want this to be in slope-intercept forms, or we want the slope to be a fraction. So we put it as 1 over 1. All right, so now let's go and get into the graph. So I'll go ahead and use black again. And then all we're simply going to do is graph each one of these separately. So my first equation is y is less than negative x plus 5. So the first thing I do is I go to my y-intercept, which is at positive 5. 1, 2, 3, 4, 5. And that's telling me to go to down 1 over 1, down 1 over 1. That's less than, so it's going to be a dashed line. OK, less than is going to tell us to go below. One thing you can do, instead of like drawing all the lines, which can be pretty confusing, you can also just kind of just show arrows of where it's going to be. It's less than, so it's going to be below. Then I get to my next one, which will be my blue. The blue line has y is greater than negative 5. And that's negative x. So now I'm going to go down to negative 5. 1, 2, 3, 4, 5. And again, that has the same slope. This one is, again, another dashed line. So it's going to be over 1, down 1. OK, try to do my best. That's y is greater than, though. So that's going to be going above it. Then I get to my next one, which is y is greater than x minus 4. So that is my green. So now I'm going to go to negative 4. 1, 2, 3, 4. And that one has a slope of up 1 over 1. That's a solid line. And that's going to be above, since y is greater than. OK? And then my last one is y is less than positive 2. That's my red, so I go up to 2. That has the same slope as my green, up 1 over 1. It's less than, so it's a dashed line. And since that's less than, that's going to be below. And hopefully what you guys can see is that all of my arrows point on the inside of this kind of rectangle right here. So that is going to be my feasible region. And that one is bounded. OK, so that means all the solutions to my equation, the solutions to the system of inequalities is going to be within that region. Whereas this one is going to be within this region, but it also expands, where this one is what we call contained. All right, so we have 2 1s. Now we have 2 we need to solve. That says 6x plus 4y is greater than negative 12. Since we kind of have those below, let's go ahead and solve them. So for this one, I'm going to subtract a 3x on both sides. Therefore, I'll obtain 2y is less than negative 3x plus 6. I'll divide by 2. Divide by 2. I have y is less than negative 3/2 x plus 3. Over here, I will subtract a 6x on both sides. So I have 4y is greater than negative 6x minus 12. Divide by 4. Divide by 4. Y is greater than, I never divided, that's going to be the same slope, negative 3/2. And that's going to be minus 3. OK, so when graphing, you can, it doesn't matter which ones you graph first. I always like to graph my vertical and horizontal lines, though, first. But it really doesn't matter which ones you want to do. So let's go and do those. X is less than 10. That, again, x is less than or equal to 10. That's going to be a vertical line, and it's going to be solid. And less than, if 10's over here, all the less than is going to be over to the left. So let's go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. That's a solid line. And it's going to be values to the left are going to make that true. Then we do x is greater than or equal to negative 2. So I go to negative 2. Again, that's going to be another vertical line. All the values that are greater than negative 2 are going to be going to the right. OK, now for our other two here, we have parallel lines because they have exactly the same slope. So when graphing a line in slope-intercept form, again, we find the y-intercept here. So we go up to 3. 1, 2, 3. And we can see the slope is a negative 3/2. So it can be down 3 to the right 2 or up 3 to the left 2. OK, that's less than. So it's going to be a dashed line. 1, 2, 3. All right. And less than is going to tell us it's going to be all the values below the line. Then we go down to negative. Then we go to this one, which has a y-intercept of negative 3. So I go 1, 2, 3. And then again, that has the same slope. You can go up 3 to the left 2 or down 3 to the right 2. And again, they have the same slope. And they're both dashed. But this one's greater than, so that's going to be all the values above. Okay? And what you can see here is the region where every single inequality is going to be true is going to be this value greater than, but less than, and be in between these. So let's use a black here. It's going to look like this to the right there. And that's going to be another bounded region. So there you go, ladies and gentlemen. That is how you graph a system of linear inequalities with 4 or more inequalities, or just 4 inequalities. Thanks.